Hi, Ray. How are you today? How
Um,
was your day? Would you like to do a short introduction of yourself, your institution that you go to currently you're studying it, and a little introduction?
yeah, my name is Ray. I'm currently a senior at Harvard College. I study math.
Yeah, so what kind of math do you study in particular?
Well, I'm kind of a mathematical baby, but I think right now I'm very interested in sort of like broadly speaking, I'm very interested in geometry.
Okay,
Um, but more specifically, recently I've been interested in complex geometry and algebraic geometry.
cool. So do you want to elaborate on so geometry? Uh, do you draw four-dimensional shapes kind of on the blackboard, or is there any dimensions that you can draw, or do you think these dimensions are perceivable, or can they be presented on a 2D plane in some way?
Yeah, so I guess I'll say I'll first elaborate on my interests, and then I
Okay.
will, I guess maybe try to answer the
Okay,
uh
elaborate your interests first and
yeah, so um yeah, so my interests, so specifically um so at least like in algebraic geometry, like what people study are like algebra geometric shapes.
mhm.
So like the most basic examples are like, for example, like you have a circle, it's cut out by an algebraic equation, x squared plus y squared minus
Yeah.
1 equals 0. So this is like one thing that I'm interested in.
What about the circle x squared plus y squared equals to r squared makes you interested? Why is it interesting?
Why is that specific equation
Right,
interesting?
because you mentioned you are really interested in the circle, and is it like why is the circle interesting? Or if it's not interesting.
No, I mean the circle is very like fundamental. It's very
Yeah.
interesting. I mean, I think in general, like the interesting things are like, in algebraic geometry, you study these shapes, but you're using algebra to say something about the geometry of the shape, or maybe the geometry of the shape says something about the algebraic nature of the shape. So there's
Mhm.
like a rich interplay between these two different ways of thinking.
Okay.
So this can be interesting.
Yeah.
Um, on the other hand, there's like sort of a different field, complex geometry, but they intersect. And there's like this famous theorem called Sayre's-Gaga theorem.
Hmm.
Um, it basically says that, I mean, like I think like roughly like complex geometry and algebraic geometry, like these are very like broad sort of like areas of study, but under certain hypotheses, there's a certain, type of objects. Like for example, like there's this like theorem where if you have a compact Kähler manifold, so it's just like it's some shape in complex geometry, and if the from this compact Kähler manifold, you can get some information out of it. And if the Kähler form is in rational cohomology, then actually this compact Kähler manifold embeds into projective space. So this is like Codera's famous embedding theorem, and this is one sort of example of how like you start with this complex geometric object, but under certain hypotheses, it purely embeds into the realm of projective algebraic geometry of projective geometry, and there you can use algebra geometric tools. So like you have these two sort of like different sort of theories and areas, but under certain hypotheses, the objects can become the same. This is all kind of very loose, but so you have these objects, and then you can use the different tools from each field to study these objects. Uh,
Interesting. Yeah.
yeah. So yeah, I'm like also interested in complex geometry, more specifically like this past year I've been like learning more Hodge theory related things. Um, Yeah, I guess people sometimes group Hodge theory under algebraic geometry, but like there's a lot of Hodge theory that is not algebra.
Hmm.
There's like a lot of like differential equations involved.
Yeah.
So it can be quite different in flavor. But anyways, yeah, I was just probably interested in like shapes and like different tools to like understand them.
Yeah, it's amazing how you make connections between different formulas in your geometric world. So let's move the timeline to your high school time. So I understand that you were a previous student council of the IMSA, so you were in Illinois during your high school period,
Yeah.
and you had different leadership roles. And also you spoke in your speech about mathematics and you were inspiring kids to further their passion in math. So would you like to share what you spoke particularly in your speech or anything that was very inspirational? Oh, so I think you were in the Illinois Math Science Academy for
Yes.
society. Um, did you do any leadership roles that you found really interesting that was meaningful?
Yeah, yeah, at the time I was very much involved with like the student government there.
Mhm.
And yeah, it was kind of almost like a half full-time job. I spent a lot of time, I mean, because we like lived on campus and like I think IMSO was a very
You
like
so you went to a boarding school.
yes, it was a public boarding school.
Cool.
Um and yeah, I mean IMSO is quite special, I think, in that like people care a lot about the community, like maybe more so than what you could say about like other high schools. Um so I don't know, there's just very strong sense of community and I think like through student government that was like something that I cared about a lot, like making like the idea of like leaving the community of IMSA better.
Hmm.
Um like before I came and then like after after I came like leaving it better for the people that come after me. Um so that was like a really rewarding experience and something I cared about a lot in high school. Also like ran like a middle school math competition.
Cool. So
So
did you um come up with these problems for other people to do, or did you
yeah,
just
so
competition?
there was like a well, I personally did not come up with the problems, but we had like a staff that like of other IMSA kids, and we would they would like design the tests, and we would have like middle school students from across Illinois come to the competition. Um, yeah, that was something that I cared about. Yeah.
Cool. So you talked a lot about math competitions, but previously I remember previously talking that you mentioned that back in high school you weren't really so math competitions weren't really your thing. Do you want to elaborate on that fact? Like
Yeah, yeah.
you have some difficulties
Yeah, yeah. I have like a bit of like a complicated relationship with
in your
competitions.
relationship. So was it hard for you or you just didn't particularly like it?
Oh yeah, I mean it was hard for me. I mean, I will also say that I like, I wasn't particularly amazing at math competition. I mean, there's lots of, you know, people at Harvard who are just like much just like who are like the best of the best at math competitions. So maybe in that respect I'm like biased. But yeah, I don't know. I think that math competitions are good for some people, but I think that for other people they're not. Um I think that they occupy a bit of an interesting I don't know, like uh I think that math competitions can be good when they inspire people and they get people interested in math, etc. But I think that there are also sort of like maybe corrosive effects of math competitions that shouldn't be overlooked. Um,
Corrosive effects like in chemistry.
sure. Like I just like I think that people sometimes default to math competitions as being like as a way of outreach. and getting people to get into mathematics and to break barriers.
Yeah.
But it's not always clear to me that this is like the most optimal way of like getting people interested in math.
So what is the optimal way to get people inspired?
Well, yeah, I guess I don't really claim to have a
Oh,
better
you don't have to be exactly right, but what do you think? What is something that is better than math comps themselves? Like this whole math competition thing to get people inspired. What's better? What's something else that teachers could do?
like I don't know. I think that like in general, like okay, so here like why do people hate math? Well, some people, a lot of people, like for example, like you meet someone, I don't know, and like you say like, oh, like I'm a writer, and then like they're like, oh, I love books, but then like you say like you do math, and then they're like, oh, like I hate math, or like I am not a math person. Like, why do people say that they're not a math person or like that they hate math? And I think that like a common diagnosis is that maybe they just weren't like they weren't shown the right like they were taught maybe math the wrong way or
Mhm.
not I mean of course like in a lot of cases it's not that person's fault. Maybe it has to do with like just pure luck or the people around them or other more complicated factor like social economic um influences.
Yeah, that's a
But
good point.
but I mean, in general, like, I think that people find that math is like very hard. I mean, it is very hard, but I think that people think it's hard and also not enjoyable sometimes because, like, math is just like, you see math, it's like all like these symbols on this piece of paper, and you're asked to do some homework and like you push
Mhm.
symbols around blah blah blah. But and like maybe you even like maybe the person even like is good at pushing the symbols and they do A implies B implies C, but this is like not really like the point of mathematics. Like I don't think that mathematics is really like what's on the paper.
Okay.
Like what's on the paper is really just like a translation or a transcription of like this phenomena. Like it's always about what's beyond the symbols on
Do
the
you
page.
prefer the digital version then, not the paper version? Or
Well,
even
even the
math
digital
not on
version.
paper? So,
Sorry?
so you prefer looking at math on your computer? Is that what you mean?
No, I prefer like doing math, like
Your brain.
like being in tune with the essence of what is going on.
So doing math in nature.
No, like like what I'm saying is that like what's on the piece of paper is not actually the math.
Oh, so it's not
Math,
present like what you can see.
yeah,
Like,
like a lot of time, I mean, like, sometimes, you have a circle, like, sure, you can see it and you can visualize it in your head.
yeah.
Uh, Is a circle just x squared plus y squared minus 1 equals 0? I mean, certainly that's one way to describe a circle, but there's a lot also about a circle that, that isn't necessarily captured by, that you can't just see from x squared plus y squared minus 1 equals 0.
Yeah.
Um, so I think that, like, maybe how people end up not liking math is like you just have all of these symbols and it's like very hard. And you have to push these symbols, but and maybe they end up pushing the symbols successfully or maybe they don't. But if they're not actually in tune with what's going on, like beyond the symbols, then they're kind of missing the whole point. And so I think that when you miss this point, then math becomes like this very not fun, enjoyable thing.
Right.
I
It's
mean,
an
it's not fun to
original
like
thought.
just probe around. Sorry?
It's a very original thought. I've never heard of this from anyone else. Good point.
Well, I'm sure other people have had similar thoughts at some point. Um,
Yeah.
don't claim to be original. But yeah, anyways, I say all this because like I think that if people were shown like that math is not just like symbols, like that there's real meaning and essence behind what's going on, I think that they would find it a lot more enjoyable. Anyways, in practice, like how do you actually get people to appreciate that?
Yeah.
Um, I'm not, I don't claim to have the answers.
Maybe
Maybe
in the future when you're
mathematician.
a math educator, because previously you mentioned that you want to be a mathematician and math professor in the future, like maybe
Oh
Barry
yeah.
Master or someone like that. Um,
Yeah, I mean, if I end up being able to teach, like, yeah, I would love to, I would like to convey the essence of what is going on and not just, doing the theorem proofs
yeah,
on the
good point. Yeah.
mechanically.
So moving back our timeline to the present as a current Harvard student, have you failed any math courses or you just aced everything and you got like 100% or did very well, got all A's?
Um, well, I haven't failed any courses, like in terms of like a letter grade.
That's
Um,
awesome. Good
yeah, I
then.
guess, yeah, I guess that's good. But I will say that like there is some sort of like um disappointment, or not dis I don't know if disappointment is the right word, but um maybe this like kind of speaks to a bit about like what we were just talking about, like what's
Mhm.
beyond like symbols. So
Yeah.
like for example, like last year I took this year-long course on like scheme theory. So basically like in algebraic geometry, like the whole field got kind of revolutionized
Yeah.
um in like the mid early 1900s. And there was this basically this new sort of mathematical language that was developed to put algebraic geometry on I don't know what's the right word, firmer, better foundations. It's a very like abstract language. Um, and so it's very e like it's very abstract and it's very easy to get lost.
Mm.
Um, and so in some ways, like, I did fine in the course, like I did the problem sets, like blah blah blah, but I kind of realized, like looking back, that in a way I felt kind of contentless because I was so like there's so many things that you have to like keep track of in this like theory. Like there's so many moving definitions. Um, and so it's very easy to lose track of like the actual geometry that's happening. And in some ways, like I would consider this kind of a failure.
Mm.
But I don't mean that in like a depressing way. Like I'm not like depressed that like I mean it's a very hard thing. Like most people like can't get it on the first try. Um
And you get everything. You just get things on the first go.
no, I the point is that I did it just like everyone else. So it's like,
Oh,
it's fine. It's like it's not a sad failure, but it is like a natural it's like a failure because I don't know, failure is maybe a weird word. The point is that like I was not actually learning the like I was not thinking I like the actual geometry behind like that the scheme theory was trying to convey, like I lost track of this. And so in some ways I felt like I had misguided myself. And then this is something that I've had to like repair over time.
yeah.
Um
It really seems like you are a person who reflects on a lot of things philosophically, on math and on a lot of aspects in life. And yeah, which is really, really good because you reflect. And so, were there any challenges that for example, how long does it, when you're stuck on a problem, do you discuss it with your friends or your peers, or how do you solve it? Do you just ask the professor, or because I've heard that there aren't solutions to problem sets, so how do you solve that problem particularly?
yeah, if I like don't
You just have no idea what's going on.
if I had like on a problem set problem.
Yeah, like a math problem set.
Oh, yeah, I mean usually I just try to think about it um for a long like at least for like an hour. Um if I'm sufficiently interested in the problem, then like, you know, could be the whole day. Um, I mean, I guess the unfortunate thing is that because like I'm in a school system, I like have finite in the context of finite time, I have like lots of different things that are trying to pull my time away from me. So
Like what?
unfortunately, well, I don't know, you just have different priorities. Like you have to go see your go you have other classes that you have to worry about. So I
Yeah.
can't spend as much time as I would like thinking about a problem a lot of the times. But usually I try to spend like a good amount of hours, and if I can't figure it out, then like I'll go ask maybe my peers or like my professors for
Yeah,
hints.
that's awesome. So I've heard that, and you previously mentioned this last year, that you've taken Math 55, which is the hardest course through history of time. Do you agree with that? Do you want to reveal some inner secrets about this course that you've taken? What's your personal experience?
Yeah. Um, well, I don't know if I would call it the hardest. I know like there's like some Wikipedia thing like hardest course in the country. Anyways, I don't know.
Overrated in a certain degree.
Uh I mean like I mean like if we're talking about like hardest courses, there are definitely courses at Harvard that are harder. Like even just in the math department, there are like some like graduate level courses that are like much harder than Math 55. Um, I mean like I don't want to say that Math 55 is I mean like it is definitely a hard course, but like I think what makes it hard is that like you're kind of cramming a lot of like the standard undergraduate curriculum into like 1 year.
Yeah.
Um,
So 4 years into 1 year.
uh, yeah, I guess it depends on the school that you look at, but yeah, I guess like 4 years into 1 year.
Oh, so you basically, so during your first year, you're basically like already done with college to a certain
Well,
degree.
the thing is that like I think also like the availability of math courses and like what different schools offer it like it depends on the school. Um, so like some schools, you know, maybe it's like what Math 55 covers is like they cover in the first 2 years, or like maybe some schools like it's 4 years.
I mean,
Um, but in
yeah,
general, like yes,
yeah.
it's true that like Math 55 is like quite fast. And so I
Who
think
was
this is
your
like
who was your educator who taught you Math 55?
Professor Aru.
Oh, okay. At
Yeah.
first I thought it was Noah Maltese, but maybe someone else.
Yeah. But yeah, I know. I think that maybe the hard part of Math 55 is that it's just very fast. So in some ways, like, I don't know, it, in some ways, like the reputation of the course is like, I don't know, like kind of weird. Like, I don't know, maybe there's like some like, oh, if you took this class, then like somehow like you're really good at, or I don't know. It's just like, uh, I don't know. I don't really know if like some of the reputation stuff that comes with Mass 35 because it's kind of like just some things are just not true or like some things are like over
Because
exaggerated.
you're doing very well. So you were like, no, this is not hard at all.
No, no, no. I that's no. I think it's just that I mean it's just a course. I don't think it's anything to be very like I don't know proud
Yeah.
of or
So Math 55 compared to, for example, your philosophy course, do you think the difficulty level between these two are comparable? They're basically the same. So that's why you don't find a particular difficulty level in, for example, Math 55. So that's why you don't think it's that hard and it shouldn't be that, you know.
Wait, sorry. I didn't mean to say that like I sorry. I don't think I didn't mean to say that Math 55 is not hard.
Okay.
I think that what I'm trying to say is that if someone finds Math 55 easy, it's usually because they've already have done a lot of math.
Hmm.
So like a lot of the Math 55 kids who like take Math 55, like in high school they already took like analysis or like abstract linear algebra. Um, and for kids who like walk into Math 55 with none of that and also don't have a proof background, in general, like maybe they don't fare as well or they struggle harder just because they didn't have that kind of background.
Mhm.
Um, so like I don't know, like this is why I'm kind of like tentative to like call like Math 55 like I mean yeah, it's a hard course, but it's just like what does it mean to like take a hard course like if someone took a hard course, like are they like deserving of the respect that comes with a hard course? And like to me that it does kind
Totally.
of like a nonsensical question. Like it's not even a question worth well obviously I mean you didn't ask that question, but like I'm just saying this because I feel like this is sort of like the implication that comes a lot when someone
Mhm.
says they take Math 55. It's like some sort of be like some sort of like credit to their name, like, oh they took this course. But it's like I don't know. It's just like it's kind of complicated. Like, it depends on like, okay, you did well in this course, but like it depends on like what you came into college, what kind of background you had, and like
Yeah, it's a very good point. So difficulty levels shouldn't reflect anything, especially math. So if a new undergrad came to Harvard, do you recommend that person, he or she, to take Math 55 if that person only took regular high school math and maybe just AP Calculus BC, for example? Do you recommend that person going to Math 55 directly or like take the easier courses first?
so like if they had like no experience with like proofs in high school,
No,
okay, like they just took AP Calculus.
BC or AV, I don't know. Or yeah.
Um, I mean, it depends on like if they're sufficiently motivated and like sufficiently like, you know, they really, really, really want to just like do math like all the time, then like sure, why not? Like, it's their life, not mine. Um, but I guess I'll say that I would probably err on the side of like, I don't know, this is like kind of a hard question. I will just like I'll just say that like because Math 55 is so fast, I think that sometimes it can make people not like math or it can make people um like it's just a very fast course. So you have to like I mean the field like the different sort of like branches of math that Math 55 covers, like there's a lot to them, there's a lot of content. And Math 55 definitely doesn't cover like nearly enough about each of them. I mean, it covers like a considerable amount for some of them, but there's also that's a lot missing. So I don't know. I mean, I think that like my best advice to someone who's interested in math, like coming out of high school, like coming to college, would just to be like, you know, just do what interests them and like to take their time. I don't think that there really is any rush. If they can handle taking Math 55 and still like, have some feeling about what's going on, then like that's great. But maybe if it all becomes symbol pushing, then maybe it's a better idea to like take things slower.
Awesome.
Uh,
Yeah,
yeah.
it's very good advice. So you mentioned that so you were in a large public high school. Um, so what did you think about the math education there? And when you transferred I mean, you headed to college at Harvard. Did you find like a huge difficulty level increase, or you think it was like a smooth transition?
So by high school you're referring to IMSA, right?
I mean, did
Um,
you have multiple high schools or
yeah,
did
I transferred high schools. So IMSA is just a 3-year high school.
oh, cool.
So I spent my freshman year in my like local public high school.
Oh,
Um,
okay.
and I transferred.
Yeah.
Uh,
So your last year of high school to your first year of college, did you
yeah.
find a smooth transition? Did your high school prepare you well? I mean,
Yeah, I mean, I'll say that like I was definitely very fortunate
Yeah,
to be able to have found out about IMSA and attended. This is much better than my local public high school. And also like IMSA just has a lot more resources than a lot of other high schools. So yeah, their math course, like for example, in my senior year, like I took an analysis course, and like uh, I also took like a linear algebra course. Um, so I would say that I was probably better equipped to handle Math 55, um, than maybe like some of my other peers, just because of good fortune.
hmm
Um, I will also say that like I did a lot of like sort of like like when COVID happened, like that was like my senior year of high school.
yeah,
And when COVID started until so that like maybe 4 month span from when COVID started and then until I started college, I kind of just like locked myself in my room and did math.
that's amazing. Very impressive. And
Yeah,
you didn't do
I don't
anything
think I
else?
actually,
Wow.
sorry.
And you didn't do anything else. You just did math all day and you
Yeah,
ate food or
it
other
sounds
stuff.
kind of like maybe it sounds kind of sad, but it was a really happy time. I think that was also probably the first time that I think I enjoyed math. But anyways, I think that all of that is to say that like I think that's where my main preparation came from. So that's made my transition to college a lot easier in terms of taking math courses.
That's really, really impressive. So, yeah, you just stuck with math. So at Harvard, were there some favorite professors? I know you mentioned some last year, but who are some favorite, who are your some favorite professors or supervisors, or who do you want to work with as a math supervisor for your future PhD or your future ongoing academia? Like, are there classes that that you enjoyed a lot?
Yeah. Um, so I'll say that like I've really enjoyed interacting with Professor Joe Harris. He's an algebraic geometer in the department.
Mhm.
Uh, yeah, I mean, I mean, mathematics aside, Professor Harris is just a very like very kind and generous like absurdly generous person. Um, so yeah, it's been a real joy and like highlight of college to be able to interact with him. Yeah, I think like
Like
in some
you
ways,
really care about the personality of that mathematician because some people really care about the abilities and skills, but you really care about the personality and how you can engage with them, like this interpersonal connection.
are you asking me, do I?
Like it seems like, do you? Like, do you really care about like the character of that mathematician or?
Like yeah, I guess it's like something to care about.
Mhm.
Uh, I mean, it's just like you're doing math and you're learning from someone. It's like it's like a human activity and you want it to be fun.
Yeah.
And you want to be productive and you want to learn. So like in some ways, like maybe personality doesn't always matter so much in math. I think there is some sense in which like there is some sort of like compatibility fit between like I just purely in terms of like if you're working with a PhD advisor, I think well, I don't know, I'm not a PhD student, but I've heard some people say that like, compatibility fit, this is like a important thing to keep in mind of.
Mhm.
Yeah, I don't know. I'm just very grateful to talk to Professor Harris and learn from him. Um, and Also, I've really enjoyed talking and working with Professor Popa, who is another algebraic geometer in the department. I'm taking his class this year on complex geometry, and that's been kind of like been besides my thesis, which like is being supervised by Professor Harris. The
Mhm.
class with Professor Popa has been like another big highlight of college. Um,
Oh, cool. What's your thesis on? Can you actually tell people about it, or it's like a secret?
no, yeah, I can talk about it. So the the words are like the project is about. semi-stability and interpolation of Veronese varieties. So I'll like decompose that. So first, this thesis is about certain shapes, and those shapes are called Veronese varieties. And so I'm investigating certain like aspects of these shapes, and the two aspects that I'm investigating are semi-stability and interpolation. So maybe like I can make a comment about semi-stable about these two things. To this shape, so I'll first say something about semi-stability. To this shape, these shapes, Veronese varieties, you can associate to them some you can extract out some geometric structure, namely um their normal bundle. And their normal bundle is just like this geometric object associated to them. I mean, like, for example, if like you have a sphere that's embedded in like three-dimensional space, if you pick a point on the sphere, you have like a vector that like
Yeah.
is orthogonal to like the tangent plane of the sphere at that point, right? So if you like collect all of these like normal vectors on the sphere, um, very loosely speaking, you can like put them together into a vector bundle. And so anyways, this is what a normal bundle is. It's like you take this shape and you're like collecting all of these like normal spaces around this shape. Um, anyways, so semi-stability is like some sort of like description or like some sort of like property about this normal bundle of these shapes. Um, maybe like in the most like very like maybe in a very like loosely speaking way. Um, like these normal bundles belong to a broader class of object called coherent sheaves. And mathematicians are very interested in like decomposing things and like classifying things. And
Hmm.
so when you have coherent, so when you have like basically like every coherent sheaf on like up to you need a little bit of certain hypotheses, but every coherent sheaf you can basically like decompose them. You can like filter them in terms of like atomic building blocks. So like just think of like a semi-stable sheaf is like an atomic building block of sheaves. Um,
Yeah.
I mean, again, it's just like it's a very imprecise analogy, but like maybe that's the best way I can convey it. So anyways, you have this shape, you have this geometric structure associated to it is normal bundle. And then in this thesis, I proved that the normal bundle is semi-stable. So in some way, it's like kind of indecomposable. Yeah.
Also, is that your new idea that you put into your thesis, or it's like a synthesis kind of like research? Do you have something new that you thought of?
Yeah, so this is like re original research.
Cool.
Um, I was working with Professor Anand Patel at Oklahoma State University,
Hmm.
Professor Harris. Um, So yeah, very, very grateful for this mentorship. But anyways, so that was one aspect of the thesis. And then the other aspect was interpolation. So like, I don't know, interpolation, like say you have 2 points, you can always draw a straight line through them. So there's always, if you pick 2 points, you can always draw a line through them. In general, like you can ask if you change, so if you call the points the interpolatees and the lines the interpolator, you can like change the interpolatees and the number of interpolatees. And you can also change the interpolators and ask a similar question. For example, maybe you increase the number of points, like, and then maybe the interpolator is like a polynomial instead of line. So then you can ask like, given some number of points, does there always exist a polynomial through them? And this like sort of goes back to like Lagrange interpolation. Um, so in this thesis, like basically like I'm investigating this question, if this Veronese varieties, they sit in some sort of like ambient space. And you can ask if you pick some number of points, does there always, generally speaking, so like you kind of randomly pick these points, does there always exist this shape that goes through them? Um, and so the answer, so um, this is like true under some certain hypotheses for these shapes.
Hmm.
But yeah, it's like whether it's like what it's like they have to be odd dimensional in degree two. That's like kind of all that I know, or just like what I made progress on.
Yeah,
Uh,
seem to
yeah,
know a lot already. So when are you presenting? And how do you present? To who do you present?
for presenting.
Yeah, your thesis. Who's gonna read it? Or
Oh, I don't know, maybe
who's
no
gonna
one.
verify it?
Well, I mean, I was working with like
Well, does it
professor.
matter whether or not what you wrote was correct? Like, would they let you graduate from Harvard? Like, what if you just wrote like whatever on the paper, and then it's like
Uh,
your last month of university gonna happen?
yeah, they probably wouldn't be so happy if I wrote some incorrect things. I think it's probably I think it's mostly correct, minus maybe there are a few typos, but yeah. I don't know. I mean, presenting, I mean, I guess seniors usually present their theses at some time and date near the end of the year. Um maybe I mean I would love the opportunity to like talk about my results like elsewhere. We'll see. I don't know.
Elsewhere, as in like where at
Oh,
college, I'd like
like
to mention
anywhere like if like
at home to your parents or
yeah, sure. I don't know if they would be happy about that, but if they wanted me to, then sure. That'd be fun.
are your parents all mathematicians if they can understand what you're doing?
No. My dad's he's an artist and my mom she teaches little kids piano.
Wow, so you're doing math and this like philosophical thing, and they're doing like arts and stuff. So that's a very big divergence thing. It's very
Well,
different.
I
Wow,
mean maybe it's different, although in some ways it's like quite similar. Like,
quite similar.
yeah, I mean I don't think like
Math and piano, math and music. Hmm.
well maybe like I don't know, like I mean, for example, like my dad, he's an art professor. So he like I mean obviously math and art are quite different, but there's also I think strong similarities.
Like what similarities do you find between math and art? They're both
I,
philosophical, as you mentioned. It's like very hard. It's like artistic.
I mean, I think in general, like, there's like some sort of commonality, I think, to like doing research. I mean, like, I haven't really done that much research, so maybe I should like, throw a caution sign, like maybe I don't know what I'm talking about. But I mean, it seems like taste and sensibility are quite important.
Hmm.
So maybe in this sense, like the actual details of what you're doing in the research, like if you abstract away all the details, then it sort of comes down to like taste and sensibility and intuition. And so I think that this is like maybe a commonality that one could draw about doing math research or like being an artist.
Do you do any art? Like, what are some extracurriculars that you do that connect with mathematics, or doesn't have to, but anything that you think that you do for fun outside of math?
Yeah, I've like this past year I like rock climb a lot.
Wow, that
Um,
sounds very dangerous, but I don't know, is it? Is it dangerous?
uh I think it's okay. Although I know some people who have like broken bones, but
Wow,
it's not I don't think it's that common. Um I think if you just yeah. Uh like sometimes I dance. Um I've been a part of like
like
the
K-pop? Are you Korean or anything?
I'm Chinese. Um but I was a part of like the Asian American dance troupe for a couple semesters.
I
It's
haven't
just some
really heard of like a Chinese dance, like Chinese pop. I've only heard of K-pop or other. Is it
oh I
like
know.
traditional Chinese dancing or?
They have like I mean it's a very big group, so some of the dances like usually they have like maybe 15-ish dances. Some of them are like traditional Chinese, but a lot of them are not.
Mhm.
Uh,
Like
I mean,
traditional Chinese country music?
like yeah, and like they have the fans or whatever. But a lot of them are also just like you play like K-pop songs and like you dance to them, or like non-K-pop but hip hop Asian artist songs. Yeah.
So did you go performing in college or just dancing for fun?
Yeah, I performed a couple times. Yeah.
Yeah, another question on the idea of being a math genius. Do you claim yourself to become are you a math genius? If
No,
someone like
no,
no.
I'm no, no, no. I'm very, very far. In fact, feel like I'm quite bad at math.
Very interesting how when I ask people they say that a lot of people say that they're not a math genius. Like why do you find this as the case? Like what defines someone as a math genius?
I just I don't know. You just the more you learn, the less you know. Uh
But the more you learn, the smarter you become.
yeah, but also the less you know. Um I don't know. Yeah, I don't know. I don't think I'm that good. I'm okay, but I'm not like great or anything.
I mean,
Uh
you're pursuing your further education in math, right? So you must be somehow somewhat competent to a certain extent.
uh I don't know. I think there's some anxiety sometimes. I mean, I just do it at the end of the day, like I'm doing it because I really like it. I try not to think too much about like, am I good enough, blah blah blah.
Yeah, it's a very good mindset. So as you mentioned, you plan on going to Germany to further your education. Between now and 1 year later, what are your plans? Like 1 year, how do you prepare yourself to become a mathematician?
Well, I don't think I'll be able to become a mathematician by the end of before I go. But
I don't know, like some first year PhDs or PhD students, they can claim themselves as mathematicians or whoever.
oh, I
You can claim
mean,
yourself as a mathematician at whatever times if you're interested in that.
maybe we have like sure, they're a mathematician. I don't know. I just like I think when I'm saying mathematician, I'm like imagining like this very like I'm thinking of like at least like having some kind of mathematical
With the
maturity.
white hair and stuff, but
I think maybe like sure,
gray
like
hair.
maybe like I don't want to contradict other people's like they can say they're a mathematician. I mean, yes, sure, I'm like I also want to be a mathematician. Um, but yes, to be plans in between. Yes, so I don't know, I just will keep doing math. I like a part of me focusing on like the complex geometry course is like in preparation for working with the person that I want to work with. Yeah. And
So
so I
why did you take like a 1 year gap? Because some people I've talked to, they just after, 4 years of college and direct PhD. So what was this why why did you if you were to say, oh, I want to do math during this 1 year period, you could have done math during your PhD times or
yeah, I think it's because like I mean it like so how this happened like Um, also, I should also say that like this is not like technically, yeah. Well, it's like kind of going. Okay. Anyway, sorry. I'm yapping. So how this like kind of happened, like in my mind, I was not thinking like, oh, I need to take a gap like before I do my PhD. Like how this sort of like happened was like very just like organically. I was working on my research this past summer, and then. Ended up using so the person I'm working with, um, Professor Hubricks, he has like a research monograph, and I ended up needing to like work through like some small parts of his monograph to be able to for the thing that I was working on. So then he was like on my radar because I mean it's just there's an interesting there's interesting stuff to me. Um, and then I was taking this complex geometry course this past year. So this was like a month later, and I realized that the textbook that we were using was also written by him.
hmm.
So I was like, oh wow, this like he keeps coming up.
You
Uh,
admire him so much that to a certain extent, like is he your celebrity crush or anyone?
um, I don't really have celebrity crushes, but I will say that yes, I do admire him. Um, I
Awesome.
think that I wish I could admire him more. Because I feel like I'm too immature to be able to like properly appreciate the mathematics he does. But whatever little sense of like the work he does, like I'm very like I feel inspired by. So that's why like this sort of arrangement of going to Germany is like happening.
Oh, so
Uh,
he's in Germany right now, or
yeah, he's a professor at the University of Bonn.
oh, cool. You want to take a 1 year gap in order to, I mean, can you
So,
just apply like for your during your fourth year and then go directly? Like, why? What was this gap for?
I mean, I guess like theoretically, like I guess there, I don't know. I mean, when you're a first year grad student, you're like you have to worry about. I mean, you have your own advisor, and like it's kind of just like, why are you going to this? I don't know. Is basically my answer is that I didn't really think about this too hard. I just like just did what I was interested in. So I somehow ended up I will be going overseas for a year. Um,
Have you ever been to Europe?
like a few times, like once, like when I was a kid, but I don't really remember anything because I have a very bad memory.
Yeah. Uh, oh,
Yeah,
yeah.
it's not a great skill to
You want to
have.
explore Europe and just it just happens organically. You're taking a 1 year gap and organically you're going to Bonn.
Yeah, I mean that's true. Like I just it kind of just happened.
Yeah, because I've heard like last year I thought you were going to MIT or something. I mean, like another institution in the US or another, yeah. It's a big change.
I mean I would love to go to MIT, but we'll see. I don't know. Well, my future is TBD. Yeah, everything's up in there.
Yeah, awesome. But yeah, that's all for today and thanks so much.